Okay, today we learned section 4.2, graphing systems of equations. Our objectives is to graph systems of equations to determine whether the solution to a system is one, infinite, or no solution. A system of equations is two or more equations, and we will only work with two in this assignment. Your different types of solutions are one solution. One solution is when you have parallel lines. They never intersect. And they also have the same slope but different intercept. So those are some things you can look for. A one solution is when the two lines will intersect, and they intersect at exactly one point. If you look at the equations of the lines, the slopes will be different. You will be asked to identify where that one point is located. Infinite solutions occur when you have a line and the second line, when it is graphed, is on top of it. So they graph as the same line. If you look at the equations, they'll have the same slope and the same intercept. So to graph a system of equations, the first thing that you're going to do is solve for y. If there happens to be no y in the equation, you will solve for x. The second step is to identify the slope and intercept to graph the first line. After you graph the first line, do the same thing, identify the slope and the intercept to graph the second line. After they have both been graphed, you want to identify the solution. You'll either have one solution if the lines intersect, no solution if the lines are parallel, or infinite solutions if they're the same line. So here's our first problem. The first thing you're going to do is graph the line y equals 2. To graph the line y equals 2, we go up 2 and graph that line. To graph the second line, because there's an x and a y, you want to solve for x. To solve for x, we subtract x. Solve for y. To solve for x, subtract x from both sides. It will cancel on the left, and you're left with 2y equals negative x plus 2. Then to get y alone, divide by 2 to everything, and it leaves you with y equals negative 1/2 x plus 1. From there, you'll identify your slope as negative 1/2 and your y-intercept as 1. And we use those two pieces to graph that line. The y-intercept is 1, so we start at 1 and we apply that slope, which says down 1 over 2, or we can go up 1 over 2. I would encourage you to notice if the lines are going to cross at some point that you want to draw those slope points, or apply the slope to graph those points on the line until they do intersect. Now, if mine was a little more accurate, it would show you that there is exactly one solution located at negative 2, 2. Okay, our second one, our very first step says to solve for y, and since there is no y, we're going to solve for x. So to solve for x, we're going to divide by 3, and it gives you the equation x equals negative 2. That's a vertical line at negative 2. See if I can graph this a little better. In class they were perfect. Okay, we take the second line, and because there is an x and a y, you need to solve for the y. So to solve for y, we start by subtracting 4x to both sides. The 4x's will subtract out, and you get y equals negative 4x minus 2. And from here you can pick out slope, because y is alone. It's negative 4 over 1, and the y-intercept is negative 2. So again, you'll use those pieces to graph. We start at negative 2 on the y-axis. We apply that slope, which says down 4, 1, 2, 3, 4 over 1. And I'm going to go the other direction, so instead of going down 4, I'll go up 4, 1, 2, 3, 4, and back 1. I'll apply that negative to the 1. I'll do it again just so I can make sure exactly where that line, where this line in red will meet the line in green. Up 1, 2, 3, 4, back 1. And there's that line. We can see that intersection, and it occurs at back 2, up 6. Okay, our last example is a little bit harder. You have two lines that involve an x and a y. So I would take that first line, and because y is alone in solve for, we can actually identify the slope right away as 2. We're going to make it a fraction, so 2 over 1. And our y-intercept, there isn't one, so we say it's 0. So to graph that line, we start at 0, go up 2 over 1, up 2 over 1, or we can go down 2, back 1. And it gives us that line. So we go to our second equation. We have a little bit of work to do, but not too much. We have to solve for y. To solve for y, we start by adding x to the other side. These x's will subtract out, and you get y equals x plus 1. Our slope is 1 over 1. Our y-intercept is 1. So we start up 1, apply our slope, which is up 1 over 1, up 1 over 1, or down 1, back 1. And we can already see that they intersect. It gives us that line. And we can say our solution is 1. It's located at 1, 2. Now I didn't show you any graphs that show parallel or the same line because I figured you guys could probably figure out what those look like without me showing you. Okay, to solve a word problem, there's steps to do that as well. The first step is to identify and label the variables. So if you're talking about pizza and cookies, you would probably say P represents pizza and C represents the cookies. After that, you're going to write the two equations. Once the equations have been written, you're going to solve each equation individually and graph each line. The fourth step is to identify the solution. You'll either have one solution if they cross, no solution if they're parallel, and infinite solutions if it's the same line. When you're solving word problems, most likely you will get one solution because you're trying to figure out the answer for both equations. The last one is to interpret the solution. So if you get 5, 2 as your solution, does that mean 5 cookies or does that mean 5 pizzas? Make sure you understand what your answer represents. So in our example here, we have the sum of Sally's age plus twice Terry's age is 12. The difference of their ages is 3 and Terry is older. Write and solve a system of equations to find their ages. So we're going to determine our variables. I'm going to say S equals Sally. Keep it easy. T equals Terry. I'm going to go back to that first equation. It says the sum of Sally's age, so Sally plus, that's what sum means, twice Terry's age is 12. Okay, for the second equation it says the difference of their ages is 3 and Terry is older. So Terry minus Sally is 3. From here you're going to graph this. Now I like to think of my ordered pair in alphabetical order, so it would go ST, and that would make T represent the Y axis or the Y variable. So in each of my equations I'm going to solve for T. So I take the second equation. To solve for T, you're going to add S, and you get T equals S plus 3. From there, my slope is 1 over 1. My y-intercept is 3. I'll go graph this. Up 3, and then up 1 over 1. Up 1 over 1. Or down 1, back 1. To get this line. Okay, I take my second equation right here, and I'm going to go ahead and subtract S over, and it gives me this new equation, 2T equals negative S, that's the subtracting S over, plus 12. And then I'm going to divide each piece by 2. So T equals negative 1/2 S plus 6. My slope is -1/2. My y-intercept is 6. So I'm going to start up 6 and then apply that slope, which is down 1/2. And I'm really glad because they intersect right there. Down 1/2, and there's my line. So I can see the intersection point is over 2, up 5, and that tells me right there that the 2 represents the S, and the 5 represents the T, so 2 is Sally's age. So I would say Sally is 2, and Terry is 5. Good luck!